All right, hello everybody. Let's continue on with our linear equations and slope. This is lesson 11.2. We're going to go to the high ratio mountain ski resort, same activity we were seeing in the previous section. So if we remember that Misty had saved her money to buy passes to the ski lift at the high ratio mountain ski resort. So they had different plans, student lift ticket prices. You could either do a daily lift ticket for $30 each day. Okay, or you could decide to do a 10-day package where you would pay $80 upon purchase, and then it'd be $20 per day for up to 10 days. Or you can do an unlimited season pass for $390. So let's take a look here. Number one, let's suppose Misty purchased the 10-day package, okay, that costs $80 plus $20 per day. So she's going to go with this option here. Let's see what she's looking at spending, for the different number of days that she might use this. So part A, can we complete the table to determine the total cost of the lift tickets in the 10-day package? We need to be sure to include the initial cost. So remember, you're paying the $80 up front, okay, and then each day you use is an extra 20. So in this table here, if she used 0 days, she's still paying the $80, okay? So it's going to be an $80 charge, even if she doesn't go at all, right? So it's $80 because that was the initial fee. Now if she goes 1 day, she's paid the $80 already, and it's going to be $20 per day, right? That's what the rate is up here. So 1 day would be $20 extra, so it'd be $120. I'm sorry, $100. If you use another day, 2 days, it would be another $20, so $120. And basically each day that you show up here, you're paying the additional $20, so $140 now. If you went 5 days, it would be another $20. Sorry, that's for 6 days. 4 days, sorry, I'm struggling. $160. And then we're just going to keep adding the $20, so $180 for 5 days. And then for 6 days, it would go up to $200. Okay, so can we explain, how do we know that the data in this table is going to be linear? Okay, so if we think about in the last section, to be linear, we need to have this constant rate of change, right? If we think about the graph, this is going to be the number of days. Okay, so 1, 2, 3, 4, 5, 6, and so on. And then the cost over here, for something to be a linear function, it needs to have this like constant rate of change, okay, which we learned on the previous section was called the slope. So that, in other words, it's going up the same amount each time. So if it goes on day 0 days, we started at 80. Then it went to 100, right? On the first day, your cost was 100. On day 2 down here, it was 120. Okay, and so on. And since that rate of change, that steepness, right, what we call slope, remains constant, that's how we know the data is linear. Okay, you can tell this also from the table. If you take a look at the rate of change, to go from 80 to 100 was up 20. To go from 100 to 120, still up 20, then up 20. So the cost is going up 20 each time the number of days increases by 1. So that change in cost over change in days remains constant at 20. And again, that value is what we learned is called the slope of the line. Remember, it's the change in the y values over the change in the x values. And the daily rate, if we recall, was it was $30 per day, right? So that would be $30 each. All right, so let's make a graph here. We kind of already started that, but just to make it look a little nicer here. So again, it was the days were the x values, and the cost was the y values. So just to have this in front of us here, 0 days we had to spend the 80. 1 day was 100. Each day then it went up by 20, right? So we'll just put the first few here, and we can see what that graph looks like again. At 0 days, we're paying the 80. So the 80 is kind of like a starting point, okay? That's actually going to become our y-intercept. Okay, at 1 day it was 100. At day 2 it was 120. Day 3 it was 140, and so on. And then it does have this constant straight line, okay, because of the constant rate of change that we have. The slope, we talked about again, it goes up $20 per day. So the slope is positive 20, because that's the rate of change. That's what slope is. And then the y-intercept, so y-intercept, here's the y-axis right here. This thing intercepts or crosses at 80. Okay, and that is because that is the initial value. That's like the price point for when the number of days is 0. Okay, on the y-intercept, the x value will always be 0. That's how you end up right on the y-axis. So that's like the starting point. All right, so let's see. Can we take a look? Can we let D represent the number of days Misty plans to ski and let K represent Misty's total cost? Can we write an equation now that could be used to determine the cost? Okay, so if we need to think about this, the cost, okay, and they're using K for some reason. I'm not sure why they didn't use C, but we'll go with it. The cost, if we take a look at here, these are the costs, these are the K values, okay, and then here's D for the number of days. If we take a look at the pattern, it's starting out at 80, and then remember they are adding 20 for each day, right? So the way we would write an equation out of that is we would start with 80, and then it's plus 20 times the number of days. Okay, so we're going to start with 80, and then we would add 20 once to get the cost for day 1. Okay, to get the cost for day 2, we would start with 80 and then add 20 twice. Okay, and so on. All right, so number 5, let's compare and contrast the lines associated with the data for the daily lift ticket that we did in the previous section. So we'll go back and revisit that with the one we just did here. So in the previous day, so for that equation, the cost using that model, so if we got the daily plan, okay, which we saw in the first section, right? Her cost for that was just $30 per day, so times the number of days. So how does that look in comparison to what we said with the 10-day package, which we just wrote the equation for here? So I'm noticing right away the daily plan, right, the one from the previous section, is just 30D. There is no like initial value. There's no constant term, right? It's just 30 times the number of days. So that's one difference. Okay, this one that we just wrote, the K equals 30D, it actually has a y-intercept of 0. Okay, if we wanted to, if we wanted to write a plus 0 on there, we could, because there's no constant term, because there's no upfront initial fee like there was before. Okay, also their slopes are quite different, right? The new one was a $20 per day charge, while the old one was $30 per day. Okay, and the reason they would do that, you might think, why would you not just automatically go with the 20 per day? The reason is because that one you're going to have to pay the $80 up front. Okay, so if you were deciding on which plan to use, it would depend on how many days you plan on using it to make these as cheap as possible for you. All right, so let's take a look here. Let's check our understanding, look at an example, and see how things are going here. So number 6, Veronica and Caitlin work in the ski shop at High Ratio Mountain. Because Veronica works on call and doesn't have a set schedule, she earns $10 plus an additional $6 for each hour she's called into work. Caitlin's earnings are modeled by the graph shown below. So let's write an equation for each girl earnings. Okay, so let's take a look. So Caitlin, or let's do Veronica first. Veronica, what did it say about her? So Veronica, she earns the $10, so it's like an upfront. She's getting $10 no matter what, plus 6 for each hour. Okay, so just be careful. It's not 16. We're not going to do 10 plus 6. It's more like 10 plus 6 per hour. So I'm going to use H to be the number of hours, right? So it's kind of like the initial amount, like the $80 from the previous example. She's getting this $10 just because she doesn't have the set schedule, and then she earns $6 per hour. Okay, now Caitlin, on the other hand, okay, her earnings are shown down here. So it looks like she's starting out, her y-intercept there is 0. So she's not getting any money up front. It's all hourly. And if we take a look at the data points here, at 1 hour, she's earned $7. 2 hours, she's earned $14. So she's earning a constant rate of just $7 for each hour. Okay, so that's the different equations. Now the slope and y-intercept, and then let's interpret them both. Okay, if we take a look for Veronica, her slope, it's going up $6 for each hour, so that's the slope. And her y-intercept, her initial value, because she's getting the $10 no matter what, okay, is going to be 10. Now for Caitlin, it's changing $7 per hour. That's how much she makes. That's her hourly rate of change. And her y-intercept, if we needed one, as we see on the graph here, would be +0 because she has no initial value. All right, number 7, let's see if we can walk through that one. So a line with a slope of -1/2 contains the point 23. Can we use the My Notes section, so the little graph paper over here? Okay, let's just kind of do this. Make a graph out of this. Oops, and we'll just use that. So the point 23, okay, here's 0, 0. So the point 23, the x value is over 2, up 3. Okay, so there's the point 23 right there. X is 2, y is 3. Okay, and they're telling us the slope is -1/2. -1/2. So if we remember, slope measures the change in y over the change in x. So the numerator is going to be the change in y. Remember, we can use a little triangle for change in. It's a Greek letter delta. So the change in y is down 1, since it's -1. And then the change in x is +2, so that's to the right 2. So what I can do, I can start at this point. If I were to go down 1 and over 2, that would be another point on the line. Okay, and the coordinates of that point, its x value is 1, 2, 3, 4, and its y value is 2. Okay, since it's a line that's going to continue, we can do that same slope again. We can go down 1 over 2 more again. There's another point on the line. Okay, the x value there is 1, 2, 3, 4, 5, 6, and the y value there is 1. Okay, and this line would go through all those points and actually continue. Okay, because remember, if it's linear, it's going to have that same slope. So we could add more and more points if we needed to. I'm just going to stop with that amount. All right, so let's get back into the ski lift problem we're doing. Number 8 here. So remember, we had the third option was the $390 for a season pass. So although that seemed expensive, Misty considered the unlimited season pass. So first, she compared the season pass to the daily lift tickets at $30 each. So how many times would Misty have to go skiing before she would save money with the $390 season pass? So if we think about it, if you can pay $390 for the whole season, or the daily pass is $30. So if we took the $390 and divided it by 30, that would get us 13. So that means that at 13 days, she would end up paying the full $390. So if you were going to use more than 13 days, then you would want to go with the unlimited season pass. Okay, so let's take a look. Let's look at this table. Part B, complete the table below for the total cost of the unlimited season pass. So remember, the unlimited season pass is $390 no matter what. So filling in this table should be pretty easy, right? If it's $390 no matter what, okay, if you use 0 days, $390. If you go 1 day, $390. If you go 2 days, $390, right? So it's constantly $390. Does that still fit the definition to be linear? Remember, to be linear, we need that constant rate of change. So let's see. From 0 days to 1 day, what's the rate of change? There's no change. It's 0. From 1 day to 2 days, what's the rate of change? It's 0. So there is no rate of change. The rate of change is 0. But since it's staying 0, right, it's constantly staying at 0, that does meet the condition, okay? That is linear. The slope of this case would just actually be 0. There is no rate of change. It doesn't matter, how many days you go. The total cost is $390 constantly. All right, so let's look at one last piece here, number 10 here. So Misty's debating these options, right? So we had, remember, there are 3 options. There was the daily pass, which was $30 per day. Okay, there was the 10-day pass, which we looked at the beginning of this section, which was 80, and then it was plus 20 per day. Okay, and then option 3 was the unlimited, which was $390 no matter what. Okay, so let's see which with these options. If she were to go skiing for 6 days, you know, what would each option cost her, and what would be the best option for her? All right, so for 6 days, if she did the daily option, right? 6 days, if it's $30 a day, the daily option would cost her 6 times 30 is $180. Okay. If she did the 10-day option, so she's paying the $80 up front, and then we're adding $20 for each of those 6 days. So we're adding $120. That would be 80 plus the 120 would be $200. Okay, if she chose the unlimited option and went 6 days, the unlimited option is $390 no matter what. Okay, so for in this case, her best option would obviously be just to do the daily package. Okay, but let's look at for other days. What if she did, for example, 16 days? Let's just jump down here. So 16 days, right? If she bought the daily rate, the $30 per day, so $30 times 16, that's $480. Okay, if she did the 10-day option, where she's paying the $80 plus 20 times 16, I'm just calculating that, that ends up being $400. Okay, or she could choose the unlimited option, which of course is always $390. So in this case, it would be smart to get the unlimited option. So just by understanding how these rates work and understanding the slopes and the y-intercepts, you're able to calculate and figure out which option you think is going to be best for you. Now, of course, you need to have an idea how many days do you plan on using it before you make your purchase. But these are the kind of things you would think about when trying to save some money on a purchase like that. Okay, so again, key takeaway today, the y-intercept of a graph, okay, is always going to be where the function starts at. If there's some initial or a flat fee, you know, like for example, let's say something started at 20, that would be the y-intercept. And then if it goes up or down by a certain amount, okay, let's say it goes up by tens, okay, it goes up to 30 at 1 day, 40 at 2 days. That rate of change there would end up being the slope. Okay, so again, for this one, the starting value, the y-intercept, would equal 20. Okay, and the slope is the rate of change. In other words, what's the change in y? How much is it going up? It's going up 10 for every time the x increases by 1. Okay, change in y over change in x. And you put those two pieces together, and you can get the equation y equals, it starts at 20 plus, it's going up 10 for each x. Okay, or as we will see, it's a little more common to write the slope part first. This is called slope-intercept form. We use it quite a bit in algebra and beyond. But either one of these are totally fine, okay? As long as you're kind of clear on what the difference between slope and y-intercept is and how they impact the equation and the graph. All right.